the system of equations. We must deal with them all at once. Always looking for solutions. Positive outlook overcomes.
Hello, my name is Roy Simpson, professor of mathematics at Cosumnes River College in Sacramento, California. In this video, I'll do a brief review of the point-slope form of a line. This topic is 2 levels below transfer level mathematics, and as such, this review will be very short. So let's get started. There are many ways to graph a line. For example, you could have been given 2 points, and all you'd need to do is draw a line going through these 2 points, and that's pretty much it. It's pretty simple. Another way you could graph a line is to have a starting point, and then once given a slope, use that slope to find another point on the line. We know from our previous material that slope is rise over run, and so if we're initially handed the point -3, 7, and the slope of the line going through that point as -2/3, we should know that if we start at the given point, -3, 7, we can then use the slope to fall 2 steps and run 3 steps. And we'd arrive at 0, 5 as the second point on our line. In both examples, I didn't actually give you the equation of the line. I just gave you some information. But we can use that information to form the equation of the line, and that is the point, pun not intended, of this video. The point-slope form of a line is the equation form for a line that you would use if given a point, and then wait for it, a slope. That last bit, slope, doesn't have to be explicitly stated in some cases, because if we're given 2 points, well, we can compute the slope, thereby giving us the required point and slope. The point-slope formula for a line is this guy right here. X sub 1, y sub 1 are the coordinates for the given point, and m is the slope. It's important to note that x sub 1, y sub 1, and m are all constants, at least at this point in your mathematical career. More importantly, however, is the fact that x and y are variables. Since this is a review video, I'm not going further into the instruction of why this is the point-slope form or how it's derived. Suppose your car has used 2 gallons of gas by the time you pass mile marker 120 on the freeway. And also suppose that you know your car gets 32 miles per gallon. Write an equation for the mile marker your car is at in terms of the number of gallons of gas you have used. I've just given you a point and a slope. How do you know? Using our problem-solving skills from elementary and intermediate algebra, we know to initially define variables for the changing quantities. The 2 quantities that are changing in this situation are the mile marker your car is at and how many gallons of fuel you've used. I hope it's kind of obvious that these rely on one another. Let's go ahead and let m be the mile marker your car is at and g be the amount of gas you've used. Guess what I found out as I was editing this video? The variable I chose for miles, which is m, will also be used in this video for slope. Slope is not a variable, remember, but still, that might be confusing. I apologize for that. Just know that we have a variable m here and a variable g, and later on, I am going to say our slope is something, and I will write down that m is equal to that. But I'm just saying that the slope is equal to that number, not the variable m. I am sorry about that confusion. Since these are 2 variables, we go ahead and graph a Cartesian coordinate system and decide which one will be your independent variable, which is also known as the vertical variable, or the output. They're forcing your hand here by specifically stating they want the mile marker in terms of the number of gallons of gas used. The language following in terms of tells us our independent or our input variable, which is gallons of fuel used. Thus, our dependent variable is the mile marker or the number of miles. Let's label the axes. Now we can plot the given point. The ordered pair is listed as independent variable, dependent variable. So for us, our ordered pairs will be gallons, miles, or I'm going to label them as g, m. Therefore, the given point is 2, 120. I'm throwing a trick at you here because some people would say Well, if I've gone 120 miles and only used 2 gallons of gas, then my car should be getting 60 miles for every gallon. The problem with that statement is that the person's making an assumption that they are starting at mile marker 0, which was not what we were told. But we'll talk a little bit more about that later. We now look at the third piece of information given us. Your car gets 32 miles per gallon. This is a rate of change, also known as a slope. And looking at our units for the axes, we see that mile over gallons is definitely the rise of a run for this situation. Hence, the slope of our equation will be 32, and that's 32 miles for every 1 gallon. So now we have a point, 2, 120, and a slope, 32. Inserting these into the point slope form, we get the following. We normally, at least below calculus, solve this equation for the dependent variable. So let's go ahead and do that here. An important thing to notice here is that if you did not use any gas, then you'd be at mile marker 56. That is, if you let g equal 0, m is 56. What does that mean? Well, it means that we actually start our trip, or you start your trip, at mile marker 56, not mile marker 0. But that's all we were really asked to do in this problem, was form this equation, and we've successfully done that. Now let's take a look at what happens if they give us 2 points rather than a point and a slope. This is actually the more common use of the point slope form. You use the following technique when dealing with applications. So here's how it works. I weighed 30 pounds when I was exactly 1 year old and 68 pounds at 3 years old. Write an equation giving my weight in terms of my age, if we assume the relationship remains linear. Again, we see those magical words, in terms of, and they tell us that age is the input or independent variable, which is also known as the horizontal variable, and weight will be our output or dependent variable. Graphing a set of axes and labeling them properly, I now write out the points they've given me, 1, 30 and 3, 68. The form is not called the point form, so I'll need to compute the slope of the line connecting these 2 points to get the slope into this. We know from our prerequisite material that the formula for slope is this. Thus, plugging in our numbers, we get that the slope is 19. Now that we have the slope, we can use either of the given points to form the equation. I'm going to go ahead and use the point with the smaller numbers because that's often the easier point to use. Plugging this into the point slope form, we get the following equation. But what does this mean? The units for the slope are pounds per year. So this means that I would gain 19 pounds per year. It also means that if we let age equal 0, I must have weighed 11 pounds at birth. Now, to be honest, humans do not grow linearly, so this model breaks down pretty quickly. And no, I actually did not weigh 68 pounds at 3 years of age, but I did weigh 30 pounds at 1 year and 11 pounds at birth. Thank you for watching this review video on point slope form of a line. As always, this content should be prerequisite to the course in which you're currently enrolled. If you found this material unfamiliar or if it was confusing to you, then I recommend you click on the provided relevant prerequisite links listed below for further help. However, if you find you're continually doing this, you might want to consider speaking with your instructor about other course options. On that note, I sincerely hope these videos help you achieve success in your transfer level math and science courses. Cue the music.
It's the system of equations. We must deal with them all at once. Always looking for solutions. Positive outlook overcomes obstacles getting in our way. Cause affects more than we can sometimes see. Things for what they are and work together until you feel at peace. Just listen close. Don't talk too much that isn't kosher. You may really hurt inside. It doesn't justify you to speak too loud and cry.